Okay, so today we are going to start our momentum unit, and I would encourage you that if you haven't already, you should be reading in Chapter 8 in your OpenStax book, or going to one of the websites from Mrs. Tu or Mr. Bozeman and watching some background information on momentum and impulse. Alright, so impulse and momentum have to do with collisions. So up until now,
Wait, who are you talking
I'm talking to my students. Impulse and momentum have to do with collisions, and I like to use sports analogies. So it could be a golf club colliding with a golf ball. It could be two rugby players hitting each other. It could be your arm hitting a volleyball.
I can't see them.
You can't see them, honey. We're making a video. All right. So impulse is defined as force times a change in time, which would give it the units of newtons times seconds. So when we're talking about impulse, we have a certain force, and what matters is how long that force is in contact with whatever it's colliding with. For example, when you're catching a baseball, the catcher increases the amount of time it takes for him to stop the ball. When you're at bat, if you're just swinging the bat, your time of contact is probably fairly small compared to if you're bunting. I don't really know that much about baseball, but you get the idea. This amount of contact time is important. So if I use Newton's second law to get rid of force and insert mass times acceleration, I could do a little algebra and derive another way of looking at impulse. So if I take acceleration, which we've defined as a change in velocity over a change in time, then algebraically those two things cancel. Let's see if I can figure out how to, there we go. Since they cancel, we get that impulse is not only force times a change in time, but it's a mass times a change in velocity. So during this collision, something changes the velocity of the object. So this gives us an important new theorem. Impulse equals a change in momentum. A lowercase p stands for momentum. And momentum is mass times velocity. So these are our two new ideas. Impulse is a change in momentum, and momentum is equal to mass times velocity. When someone says, I couldn't stop, I had too much momentum, they're right. You get more momentum by having mass or by moving faster. So like when a little guy is really good in football, he might not have a large mass, but if he's fast enough, he has enough momentum that in a collision, he might win that tackle. Let's talk about units one more time. Looking at this equation, mass is measured in kilograms, velocity is measured in meters per second. And earlier we had said that impulse is newtons times second. Well, a newton, which is a mass times acceleration, kilogram meter per second squared, times seconds, this second cancels this one down here, so a newton second is the same thing as a kilogram meter per second. Alright, that's kind of your base information. Today you're going to be doing a lab where eventually you're going to measure the momentum of an object before and after it has a collision. At first it's going to collide with the floor, and then it's going to collide with another ball. Okay, the second big idea is conservation of momentum. And this is a lot of information to see all at once, but the information or the idea behind conservation of momentum is that your total momentum in the beginning is equal to your total momentum in the end. So it depends on the system. The total might be a golf club plus a ball, plus the golf club plus the ball. Before and after are always equal. It could be football player A, football player B, football player A, football player B. Okay, so we're not really doing conservation of momentum today, so don't worry too much about this. I just introduced this in my classes yesterday as background knowledge. When we're looking at conservation of momentum, there are three types of collisions we might look at: elastic collisions, inelastic collisions, and completely inelastic collisions. In elastic collisions, both momentum and energy are conserved. In inelastic, momentum is conserved, but kinetic energy is lost. Some of that energy is lost to things like heat, friction, sound. Completely inelastic is similar to inelastic in that momentum is conserved but energy is not. But in a completely inelastic problem, the two objects stick together after the collision. Troy, please don't. That's where we have the most energy lost. Okay, so that's your information for today. What's going to happen? You're going to do a lab, and in the first part, you're going to drop a basketball. The lab information says to drop it from 20 centimeters, but you can drop it from about 50 centimeters. You're going to drop it and see how high it rebounds. What we're trying to figure out is how fast is it moving the split second before it hits the ground, and how fast it's moving right when it leaves the ground. You know, it's colliding with the floor, so there's impulse, there is a change in velocity. So you're going to drop a basketball, a ping pong ball, and then I have a couple different little balls I got from around the house that you can drop for your third ball. For that part of the lab, eventually you'll do calculations where you either use conservation of energy or kinematics to figure out those velocities. For the second part, you're going to drop one ball sitting on top of the other ball. What happens is the bottom ball is going to hit the ground and bounce back up and collide with the ball that was on the top. For that lab, you need to wear goggles. Trust me, you don't want one of those balls to hit you in the eye. So what you're going to do there is, again, drop the balls from the same height you did in the first lab and measure where they both rebound to. It's a little bit trickier, but you're going to try to collect all of that data today. Once you have all of your data, you're going to start calculating just velocities. Don't try to do this whole lab because I need to teach you more information. But if you're fast collecting your data, then you could just calculate velocities before and after collisions. That would be fine. You might want to use your cell phone to video record it. Sometimes it's very hard to see exactly where the ball rises to. You're going to be working down in the cafeteria. Please best behavior. Try not to lose any of the balls. Those are little basketballs for my kids. They would be upset with me if they don't come back. You have a web assign you should be working on. Look through it. You're not going to try to do all of it. I haven't taught you everything yet. So just start it. And when you try a problem, if you get stuck, please send me the Ask Teacher for Help notification and I'll try to get back to you on that. Okay guys, I hope you have a great day. Thanks.